Hello everybody, we're going to be working on the second set of Python exercises today, and I'm going to pull those up on the screen here just so we have a point of reference. So this is the Unit 8 folder. We're working on the Python Review Exercises Part 2. I have preemptively opened up the Word doc that we're going to be working from, and I've also done a little bit of file management in the background. So what I'm going to do here is just show you what I've done. I tend to keep everything in my Google Drive, and then I organize things by courses, and I'm sure you guys do something similar. And then I created a Python exercises folder inside of my Data Analytics 1 folder, and then I just created a folder called Python Review Part 2. So the first thing I'm going to do is I'm going to go ahead and get into my IDE here, Spider, and I have preemptively created a new file. And then, of course, the first thing that I did, and I just, as a matter of practice, I always like to point this out, is I did a save as, and then I chose that file location to store my exercise. I did name it exercise 7_1, just so I can find it a little bit easier in the future. The other thing that I did is inside that same folder, which I'm sure some of you caught, is the fact that I put in a brand new text file. And the way that I did that is I just did a right click, I chose new, text document, and then gave it the name hello text. If you open this up, this is a blank file. There's nothing inside of it, but it will be called for by the program that we're just about to write. And I'd like to do that preemptively, knowing that that's going to be the case. The other thing that I want to point out is here in the File Explorer for Windows 10 and Windows 8 is very similar. They have this little thing you see that I'm clicking on here that activates the ribbon bar. I want you to make sure that you go to your View menu, whatever folder you're working in, and make sure that your file extensions are turned on so that you're not misnaming these files that we're going to try to read in. If you hide your file extensions, what some students will do is they'll call it hello.txt, not knowing that it's also .text after that, so it's hello.text.text, and then when you turn that on, you see the real name, and it confuses you. So my advice to IT professionals is always leave that turned on. You don't have to turn on these other ones, but I think that one's pretty important. It's under the View menu. All right, let's go back and take a look at the instructions. It says open a file with the name hello text. All right, so that's the file that we just created. The other thing that we want to do is store the message store the message, quote unquote, hello world in the file, close the file, open the same file again, read the message into a string variable, and print it. Now, these are very rudimentary tasks, but if you can't do these, you're not going to do a lot of data processing, obviously, because you're going to have to kind of use that process over and over again. So that's why this is a really important exercise in my mind, for as simple as it is. All right, let's take a look at how to solve this. So I'm going to go back to my IDE here. Let me get my cheat sheet up on the other screen here. And what we're going to do first is we're going to recognize the fact that Python has a number of commands built in that allow us to do some of these things automatically. They're just part of the standard Python libraries. So one of them, one of the commands that you learned in the chapter is open. Another one that you learned about is called write, and there's close, and all those. And I'm going to show you how to work with those. The first thing I'm going to do, though, and this is, I'll tell you what, this is probably, I would say, optional, because you can hard code these things in. But I was thinking to myself, and a lot of programmers think this way, that, well, what if you wanted to put something else into the file name or change the file name that you're working with? So the first thing I'm going to do is I'm going to set up two variables. Notice how they're all uppercase, so we're assuming they're kind of constants, but you know that that's not really the truth in Python, so you can change those if you want. But I put in a message, a string that just says hello world, the message that we want to get into that text file. And then I also created a string variable to hold the name of the file itself, so I could change that by just changing this one line here in the code. Now, what I mean by the fact that you don't necessarily have to put that stuff in variables is you can just hard code it into the opens and the writes and the closes and all that you're about to do. So the first thing I'm going to do is I'm going to set up another variable here, and I'm using like some of the terminology that is, I guess, common to a lot of programming, which is this in-file and out-file approach. And the way that we do that in Python is we just say open, we put in the file name, and then notice the little switch for W, which means that we're opening it with the ability to write. And then you know that in some cases you just open a file and you read it in, do something with it, maybe write it to a different file. Also not common, but we're opening, the file hello text to do some writing. The next thing that we're going to do is we're going to take that message that we want to send to it, and we're going to write back to that file. So at this point, we're attaching it to the file that we just opened, and we're issuing the write command. What are we writing? Hello text, and we're adding a new line character. So it's going to say hello world, and then a blank line. And then, of course, whenever you're dealing with a file, you also want to be polite and close it. Otherwise, you could run into problems. So if you are reading and writing to a file, and you're writing a message, and let's say it doesn't complete, you stand the possibility of corrupting that file or the data that you're putting in it. All right. Next thing we want to do is we want to read back that message and display it. And so the way we're going to do that is now we're going to use the in-file command. So we open the file, we wrote a message to it, and we closed it, which saves it. Now we're going to do the process of just opening it and reading it, and we're just going to use the open command again. But notice the switch is changed to R for read only, so we're not concerned about changing it. And then we're going to take what is inside that file, and we're using the read line command. We'll just read one line at a time and put it into a variable. So, and that's attached to the file that we just opened. And then we'll take the message that was inside that file, and we're just going to print it to the screen. So let's go ahead and run this. Let's save it, hit the run button, and the file contained hello world. Now we can check this, because here in my Notepad++, I'm trying to get this over to the other screen here. Okay, so here's my cheat sheet. We are going to open up that file and just drop it into Notepad++, and you can see there it is. And notice how there's a blank line after it, because we did put in a new line character. Now you can make that message as complicated as you want, make it multiple lines. That's not really the point here. The point is open the file, write to it, save it, open it up again, read it out. Then we're also going to the file to just double check that everything is there that we need. So that one's not too bad. Let's move on to the next exercise. So let me bring up the Word doc here. Exercise 7.4. It says write a program that reads a file containing 2 columns of floating point numbers, prompt the user for a file name, print the average of each column. So now we're doing a little bit higher level type of thing. So we're actually going to take that data and manipulate it and do a little bit of math with it. So getting a little bit closer to the data analytics kind of stuff that we want to be doing with our programming language. All right, so let's get that out of the way. Let's start by creating a new program. And let's do a save as. And this is exercise 7.4. And save it. Now, one more time back to those instructions. Okay, it doesn't tell you what to call anything, which is actually kind of helpful. Now, what the author has done to help us out is, if you look at the source files that come with your book, he does have files pre-created for us, and I'm just trying to find them, with some of the things that we're looking for. So he actually pre-creates this file called input.txt, and if you open that up, what you're going to see inside there is this. You're going to see two columns of numbers called input.txt, and you notice that the instructions say floating point numbers, right? Now, remember, Python doesn't care what kind of number it is, so we have one that's a standard integer and one that's a floating point number. And you can come in here and you can change these or tweak these or do whatever the heck you want with them, make it something completely more complicated or simple. The one thing I do want you to notice, though, is if you are looking between these numbers, how they're split apart. You know, there's two columns. You see how there's no tab stops in here. This looks like it's all spaces. And then when I go to the end of each line, it just jumps right into the next line. And that's, you know, what these programs look for, is when they get to that last line and hits it, then they know the file is done. All right, so this is the input file. You could either create this from scratch, pretty simple, or you can find it in the source files for the book, up to you. All right, so once again, we have, you know, kind of a similar type of task to accomplish. The first thing I'm going to do is I'm going to write this snippet of code here. So we're going to read the file name from the user. So we're asking the user for the file name. So if you wanted to create a different file, or if you have a file with two different columns of numbers, hey, go for it. Pull it in. Just a text file, doesn't really matter. And then they're going to type the file name for us. We're going to store it in the variable, and then we're going to open the file in read-only mode. We don't need to change anything in that file, so that's why we're using the R switch to read it in. The next thing that we have to do is we actually have to read in the lines from the file and then start to process them. So now there's a little bit of thinking that has to go in here, because if you're going to read in these numbers, we have to recognize that they're coming in columns. And if you read the instructions, what they're really asking us to do is to take these numbers here and identify that even though they're written in a line going across, we're going to associate them in a different way. So we're going to take, you know, the first thing in the column and then the second thing in the column and treat them as two different pieces of data. And Python offers a number of different, you know, built-in methods that allows us to work with those things. So, and then we have to do math with them. So let's go ahead and think about how you would do that. If you're going to average numbers, the first thing you have to do is you have to add them all together and then divide by the number of total numbers. So at some point in time, you have to keep a count of how many total numbers you're working with. So I'm going to create a variable for that. Since we're working with two different columns, each column is going to have its own total. So I'm also creating variables to hold those. Presetting everything to 0 because we're starting with nothing. Now we're going to go into a loop. So here's where it gets a little bit more interesting. I'm just going to paste in this whole thing and then talk us through it. So I have this snippet of code here for line in file. So what it's going to do is it's going to read each line of the text file that we just read in, and then it's going to take the line and split it. Now if you remember what the split command does, it looks for those spaces in there or whatever, you know, the other stuff might be in there delimiting the file, and then breaks the data apart into pieces. So once it's broken apart into pieces, right, so we're going to take each position in each column. So the first column is going to be position 0 in parts, and the second column is going to be position 1 in parts. We're taking that and we're feeding it through the float method because we want whatever's in there to be treated as a floating point number. So this is why we have, you know, one set of numbers without the decimals and one with, to show you that we are doing the conversion in the process there. Also remember that when you're reading stuff in from a text file, it is text, not a number. So that's the other part of the process here, is we have to do that conversion to actually make it a number that we can do math with. Once we have that converted to a number, we're going to add it to whatever is sitting currently inside each one of the total fields. and then we're just going to repeat the process, adding 1 to our counter each time. And as we do that, it will pull together the information that we need in order to calculate the averages and the totals and everything. Next thing I'm going to do, and I put that in the wrong spot, is now that the loop is done, I'm going to issue the command to close the file because we don't no longer need it. So we read through the data, process it, close the file, release it for somebody else to be able to use it. Finally, via one simple print command, and you could do this a different way. I know that you could do the math, store it in a variable, output the variables, that's fine. I decided last time I did this that it was more efficient to just do a little print formatting and do the math directly in my statement. So I came up with this little statement that basically will figure everything out to 2 decimal places in format. And then we're taking whatever totals, divide by the count, whatever totals, divide by the count, and then it will give the average of the 2 columns. So if we save this and run it, and notice it's asking us for the file name, and we called it input.txt. It says the averages are 2.5 and 5.0. Now, you should never take this stuff on faith, especially when you're writing a program from scratch for the first time. You should always do your math. So what I'm going to do is I'm going to put my calculator up on the screen. Yeah, it does not need to be even close to that large, and just do the math. So if I add 1 plus 2 plus 3 plus 4, that equals 10. Divide by 4. Oops, that's not what I put in there. So the total was 10. Oh, I see what's happening. My numlock's not working. Okay, there we go. All right, let's try that again. So we had a total of 10, and we divide that by 4, and we come up with 2.5. So the first column's answer is correct. And then obviously we know that the average of 0.5 repeated 4 times is 0.5, so it seems to be right. So we're good with the math. It seemed to work just fine. The other thing that I'm going to point out to you is let's see what happens when the file name is not correct. All right, so you see how it just throws an error message. Now, this isn't the most elegant way to handle that. Frankly, really you should write some code to do some error catching, like an if statement. So like if it's not found, you put an error message on the screen. So you could put that into the program, and some students will, because they feel that obligation. Really what I'm looking for is the functional part of it, knowing that you can type the name in correct and make it work. However, if you were really doing this, let's say for a user, absolutely you would want some sort of a mechanism in there to stop false entry and not break things, basically. All right, let's call that exercise done, and let's move on to the next one. All right, let me get this screen out of the way and pull up the Word doc. So the next exercise that we have is exercise 8.4. And this is actually kind of a cool one because, last batch of exercises we worked with the Fibonacci sequence, which is a very interesting set of numbers. And I forget from the research that we put up on the screen from Wikipedia or wherever we pulled it from, when they came up with the Fibonacci sequence. But if my memory serves correctly, it happened during, what I would call the Age of Enlightenment, or after the Renaissance had begun. So probably like 14, 15, 16, 1700s, something like that, which is really recognizing a pattern of numbers and its outcomes. This particular algorithm that we're going to be looking at is called the sieve of Eratosthenes, I think that's the right way to say it, who is an ancient Greek mathematician, and it's a function that you use to compute prime numbers. Now remember, a prime number is a number that can only be divided by itself and the number 1. And the Greeks a long time ago figured out this pattern for doing this. So I think that it's always interesting when you place this in a informational perspective, like if you actually go to the trouble of doing a little bit of research here. So I'm just going to pull a tab over and just type in that search. Let's go right to Wikipedia. And what they do here is they show prime numbers. And I want you to watch this graphic as it goes through. So first thing it does is it eliminates everything that's divisible by 2, everything that's divisible by 3, everything divisible by 5, by 7, 11, 13, and it just starts climbing up the prime numbers. So whatever numbers are left in gray are the numbers they start dividing by. And then you see the ones that end up in purple are the prime numbers. So they go up to 120 here, and they show you all the prime numbers. Now, as you get to larger and larger numbers, it becomes... Achoo, thank you. It becomes harder to hit a prime number as you get larger numbers, because larger numbers are more than likely possible to be divisible by something else. They actually have computer programs that run continuously looking for the next prime number, because in some ways those are kind of considered magic numbers for doing some really high-end math. And they have charts of these that go up, into super large numbers. But when you get past a certain point, it's pretty much only computers can do the math to figure out what's left. So they've been calculating prime numbers for a while, and like I said, they have some computer systems that continuously run it looking for that next astronomically huge number. So I don't know how they're doing with that these days. I would think that they probably have some interesting ones generated. But there's an algorithm here, and that's really what we're concerned with, because when we're programming, we need to take the logic of whatever that sequence is and convert it into something that makes sense for programming. So take a look at what they do here. So a prime number is a natural number that has exactly 2 distinct natural number divisors, the number 1 and itself. So everything is divisible by 1, obviously, but not everything is divisible by multiple things. To find all the prime numbers less than or equal to a given integer n, so that's what n indicates, like the limit. So like in the chart above, up to 120. Create a list of consecutive integers from 2 through n. Now, they don't include 1 because 1 goes into everything. So that's so they basically show that as we start at 2 and we go up to whatever number you apply. Initially, let p equal to the smallest prime number. Enumerate the multiples of p by counting in increments of p from 2p to n. So in other words, what we were saying above. First, we just start with the number 2. What does 2 go into? And eliminate every number that it goes into. And then we just basically keep going. So they, show that, the method for doing that. Find the first number greater than p in the list that is not marked. Okay, so in this case, if you look at what happens above, we'll wait for the thing to reset here. And I think this is really fun to watch, right? So first they take the number 2, and they see, does it go into 2, and etc. And then they start building this silly little list here. All right, and then when you get through this algorithm, basically you're gonna find all the primes that are listed below whatever whole number you typed in. So another way to look at it is you can do stuff like this, and this is something that might help us, algorithmically at least. So it says first you get a list of numbers. Okay, so you do that. Then you start going through and you start dividing by number. And then, of course, when you divide by a number, you're looking for no remainder, right? And then you start eliminating. Then you go to 3. Then you go to 5, et cetera, and then you just eventually end up with whatever is left over through these numbers. And then I think what's really fascinating here is, thank you very much, Wikipedia. Here's some actual pseudocode that is really close to programming code. and you can use this sort of as a guide. So we're kind of working off of this a little bit and with some alteration. So let's go ahead and get to the coding part of this. This gets pretty interesting. Let's start by creating a new file. Let's do a save as on that file. And then I need to remember what number this was. This is 8.4. So let's call this 8. Let's exercise 8_4. And I'm actually going to add to it prime numbers. Now this is kind of a classic programming exercise, and if you've done other programming classes where you learn algorithms and things like that, there's a good chance that maybe you've done this type of exercise before. So, and that's okay. Nothing like a little repetition to make it clear. But it's fun to play with algorithms like this because they do pose some interesting challenges for us in terms of the logic of how to apply it to a different program. All right, so I have my little cheat sheet here, and one thing that we do need to know here is if you look at that algorithm that we just were examining, the first things I want you to notice are the types of math that we're going to do. So one thing for sure is I'm noticing a square root sign in here. All right, so that right there indicates that we need to pull in some math libraries, because you can't just like say, hey, give me the square root of a number. And so we need to have that in there. So they have this little thing here. It says not exceeding the square root of whatever number we're trying to get to. So I want you to think about that carefully. If I had a list of numbers up to 100 that I'm trying to do this for, 100th's square root is 10. So what this is telling us is that if you're trying to check all the prime numbers from 2 to 100, I don't need to check any divisors past the square root of 100, or the number, my target number, because everything will be covered by that point. By the time we will have figured out, basically, by the time we get to the square root of the number that is our target, we will already have divided through and gotten all the prime numbers in the sequence. So somebody figured that out to be a truth here, and so that's one of our limitations. So we don't go all the way up to the number and divide through everything by 99, for example. Not necessary. We only have to go up to 10 to make it happen. So we do need some math imports. Now, aside from just working with the square root, we're also going to have to do some division in here if you start thinking about it. So the two libraries that we're going to import from the math libraries are the square root and the floor. And remember, floor division gives you how many times something goes into something with without the remainder. Okay, so that's part of it. It does flag yellow initially because we're not using it, but we're not worried about that. If you read the description here, this function, blah, 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 blah. First, insert all numbers from 1 to n in a set, then erase all multiples of 2, blah, blah, blah. It gives you the algorithm for doing it. Now, what we are going to do is we are going to put a front end in, and I'm copying this from the author of the book. So what he suggested is that we have an input so we can actually change the number we're targeting. So we'll start with maybe like the same list that we saw in Wikipedia, going up to 120 and see if our numbers matched up. That can be our check, basically. And then we can get fun with it, and then you could put in some really large numbers and see how many come back, just for kicks and grins and giggles, as they say. The other thing that we're going to do is once we have that number set, is we're going to take and populate a set. So now I want you guys to remember that, you know, with all the stuff that we learned about lists and dictionaries and all that stuff, we're really putting in a set of numbers here, and we're setting up a range. Now I want you to notice something here really carefully. Why are we adding a +1 to n? Because you should know that when you are declaring a range in Python and you go from one number to the next, it always stops one number short. So you have to add one to whatever your target is in order to get to the target number. So that's the why. And what this one will do is exactly what line 13 says. All the numbers from 2 to n. So if I put in 120, this will, if I just left it with 2 comma n, it would only go up to 119. It would never hit the 120. That's why we're adding it. I think I already said that, but sometimes it doesn't hurt to reiterate. Now here's where the real work comes in, and it's all happens in a loop. And what I find is really interesting about this is the logic that we take for granted here is that mathematics does this stuff. And when you start to learn about calculus, for example, and you look at something like this could like scare you to death. And somewhere in here, all right, and this is, you know, the thing that I'm looking for. So if some of you may at some point in your lives have studied trigonometry or calculus, but the little expression that you see on the screen there with the big Greek letter sigma is an indicator of working with numbers over ranges with limits and responses that can be more complicated than just a single number. So that silly looking little equation here actually tells us the same thing that this whole pseudocode tells us. And this is, you know, I, as a math person, you know, kind of being forced into it by, you know, taking computer science on a bachelor's level. You know, we had to go through, I think, 2 levels of calculus on a bachelor's level, and I had to throw in a 3rd level in my master's degree. And like so many math courses, it's almost ridiculous. But you can read these equations, and then you start to see these correlations between that and what we do in code. So what we have to really identify here is how we accomplish that same thing programmatically. So this is going to actually require 2 loops, and this one's not always very easy to describe, but we already figured out that, you know, we're going from 2 to whatever that limit is from the number that we're putting in. So, you know, once again, to the square root, we don't need to check every number in between, just up to the square root of our target number, plus 1. And then we're looking at the floor of that square root. So what that means is we're not looking, so like if you put in a number like, I don't know, 101, the square root of that's going to be just slightly more than 10, but let's just use 10. You know, that's what that's saying. That'll get us close enough. That's the reason for that. So as we go through each number, then we're going to go through and basically take n, and if you guys remember, this once again is floor division. So we're going to divide everything by what's left over, and we will go through and start to do some discarding. So what we're going to do in terms of discarding is basically we're going to multiply the 2 numbers that we're searching through. So this is a little bit where it gets a little fuzzy, perhaps, because whatever position we're in the outer loop, the main loop, so we're going to start at 2. So the first iteration through this is a 2. And then when we go into the inner loop, that's also a 2. So what's 2 times 2? 4. 4 is clearly not a prime number, and we're discarding that number from that set. And the range, and this is where it gets a little interesting. So the range starts at that first position. So they find the 4, they get rid of it, and pull it out of the list. So what we're doing basically here, and it seems almost like magic, is we're really taking that weird calculus formula, converting it, you know, to programming code, and having the code do that work, which is indicated in that formula. And this is one of the big challenges that we have, because there's all these great mathematical formulas. Converting it all to programming code is not always kind of the cleanest thing. If you look at like just the whole proof that goes into it, to kind of break it down, I think it's pretty darn amazing that people were figuring this out. Now, if you think about that, they took what the Greeks were doing thousands of years ago and converted it into like a modern algebraic formula so that we can convert it into computer code. It really is kind of mind-blowing that people without technology behind them were able to figure this stuff out and then utilize that knowledge to do some really sophisticated things. So this is the formula that makes it happen. The thing that I find fascinating is you might not figure this out on your own. And some of my students, frankly, went out and just, did a search Python code for whatever, and then they'll find, this or variations of this. And in some ways, I can't say I blame you, because I don't expect you guys to have that kind of level of mathematical knowledge, but it's kind of interesting to look at either way. The final part of this is actually putting the stuff on the screen, so we're going to display the primes, and the primes that are less than or equal to n are. So in other words, if I put in the number 120, it'll give me all the prime numbers up to 120. The way that we're going to do that, once of course, is by taking that list of primes. So that, list or set, or however you want to think about it, of numbers, with certain ones extracted. Now, part of the problem with the math of this, if you were to step through and do all the math for all the items that you're discarding, you might not necessarily end up with a sorted list of numbers. And so one of the things that we're going to do is we're actually going to sort those numbers. Now, if you remember from your readings, or maybe you don't remember at all, that's fine. There is a very basic sorting algorithm included in the Python libraries. It just orders things from smallest to biggest. And I'm just running that over our list of numbers. And then we're just outputting them with a space in between. So this is all the code that it takes to make this work. It seems ridiculously simple, because it kind of, in a way, it kind of is. Doesn't seem that way, but it kind of is. It's more the logic that's complicated. So let's go ahead and run this and see what happens. So it says enter a positive integer. So we're going to put in 120, and then there is the list of all the prime numbers up to 120. Now we can jump back over to our good friend Wikipedia here, and if you can grab that before it goes away. All right, well, it went away. You can verify that the numbers in there are the same numbers that we have, and I was hoping for maybe a concise list here, but I think maybe what I'll do is I'll get poised to screen grab it as soon as it is ready. I don't know if, it seems like it just delayed it. All right. I guess I just wasn't fast enough for it. And then you have to grab that. But it looks like this little list is the same. It looks the same number of numbers. It starts with 2 and ends with 113. So I think we're okay. Let's have a little bit of fun with it and put in some numbers that are significantly larger. So let's put in 999,999 and see what that does. Now this is going to take a little bit more time, because it's going through and it's doing all the math up to that point. So what took seconds before now is going to iterate through nearly 1 million times. So and actually, if you think about it, only up to the square root of 1 million, which of course I think is 1,000. So this is only iterating 1,000 times in the outer loop, and then 1,000 times, or up to 1 million times in the inner loop, right? Because this one doesn't go off the square root. So you can see it's taking a little bit of time. And I really find it kind of interesting that they have this little memory indicator down here. I'm only using half the RAM on my machine right now. But you wonder, like when you do like these computations, if there's any functional impact on the RAM. Apparently not, because this is one process. But you can see how long it's taking. Just as a point of reference, I have an i7, maybe like third or fourth gen i7, 16 gigs of RAM, all SSD. Not that that matters much, but you see how long it's taken to calculate this. So I'm letting it run, and maybe this was a mistake. We'll see if it even resolves by the time we move on to the next exercise. I'm actually going to pause the video because it's not really very fun to watch a computer do math in the background that you can't even see. And if you wanted to see what it was doing in progress, you could actually throw in like a little print message here and say, for each iteration, and you could see the iterations come up on the screen, so it's actually doing something. But notice how long it's taking. So I am pausing. It's already maybe a minute in, so pausing now. All right, so it took almost several more minutes here. I didn't actually look at what my system clock said, but I think it took another 3-4 minutes after I paused the video. But you can see here the list of prime numbers. Now, what I find really fascinating about this is you would think that as you get to bigger numbers that there's actually less prime numbers. But oh my God, that's really not the case. There are many prime numbers. And you can see that the pattern for it is not very, predictable, I guess. Maybe there is some way to predict it, I don't know. But it's a huge, huge number of numbers. And I think it's fascinating that if you had the intent here of maybe running this to termination with a super large number, you could put in whatever Python can handle. And as we saw with one of our other exercises where it generated like some number that was like pages long, Python is able to do this. Not a lot of programming languages can do this without like modifications or special libraries, but Python is built for this kind of stuff, and I think this is fascinating. Now, if you start to think about the fact that we have computer systems that are crunching numbers that are probably astronomically huge, and what they do with those prime numbers, I think is interesting. All right, let's move on to the next exercise. Okay, so next is 8:17. It says write a program that reads data, and we have a website here, and into a dictionary whose keys are country names and whose values are per capita incomes. Then the program should prompt the user to enter country names and print the corresponding values. Stop when the user enters quit. All right, let's take a look really quick at what needs to be done here. So first thing is let's grab this URL and see what they're having us look at. And I do like one thing about our Python book that we use is that they have some really cool links to data like this. And I want you to notice the URL as well as I drop this into the browser. This is from the CIA, and they have raw data, for all sorts of things. And I don't know at this point, like if we could pull up different years by typing this in, but this is basically the information. So it's just a text file that has a column number, the name of the country, and then I'm guessing this is the per capita income per country. And I didn't mean to go back there. I meant to do this. Yeah. Country names and per capita incomes. And then I think the thing that always shocks a lot of people who live in the U.S. is, we have this assumption that we're like the richest country on earth, and we're not even close. In fact, a lot of other countries take care of their people I'm not going to say better, but in different ways, and in many cases have systems in place that support people or share the revenue that the super rich are making on like oil or whatever. So people are doing pretty well. So, I mean, who was to know that people living in Liechtenstein in 2004 had an average per capita, that's like per person, of 140 grand a year. I mean, if we could only do that in the States, think of how well off everybody would be and not struggling. That's not the case, though. U.S. at that time was around 60K. I'd be really curious to see what those numbers are now. And I had this suspicion, I don't know if I tried this, like, is it possible to look at, like, do they have this information? Nope. Okay. So that's not a value. You can't just change the date on here. So there must be some mechanism in there for finding it. But here's a piece of raw data that we can pull up as a text file. Because it is a text file, you can actually do a save as on this and save it as it is. So you can, in your browser, it's not something we normally do in a browser is a save as, but you could also do this. And I'm just thinking the easy way to download this, or have we in essence already downloaded it? So I think a couple different ways we can do this. We maybe do view source, Control A, Control C, bring up our text editing tool of choice, for me, Notepad++, and then just paste it all in, and then see how it's coming in. And it's not coming in quite as beautiful as I would like, for whatever reason. It's you know, scrolling the lines down and you think it's not coming in right, but really what it is there's a word wrap on there. If you look here, you notice how there's all this extraneous white space. I'm not really quite sure how they're orchestrating this. Are these tab stops or spaces? It looks like they're all spaces. Sometimes you get these text files and they're already kind of manually formatted like this, so who knows how they formatted it, probably with a piece of software. Sometimes you get these files and there'll be commas in between the values or tabs in between the values, so comma separated values or tab stops. In this case, just spaces, and at the end of the line you got a boatload of spaces for some reason. Now, nothing we have to deal with manually. So like in the old days, and I think about some of the like old data entry work I did when I first got into IT, especially as a temp, you know, they would sit you down with like files like this, and they didn't have like the processing capabilities that we have now, and they would say, okay, all right, you go ahead and you take all this information and move it into our database, for example. Now I could probably just create a Python program, convert this list into comma separated values, write it to a file, feed it right into a database, and boom, it would work. Back then, a lot of times you had to kind of manually come in here, and maybe my task would have been something like, you know, go to the end of each line, go Shift N, delete all that, you know, et cetera, and do it all manually, if you can even imagine that. But that was the kind of trivial stuff we would do back then. Now I'm going to take this file that I just created here, and you see I didn't paste it on line 1, which is not good. And now I'm going to go ahead and save it. So let's do a save as and put it into our folder. And this has got to go into the data analytics folder. Let's just call it raw data .txt, and let's save it. So now we know what it's called. I know what my naming convention is because I always use lowercase, but I'll also keep it open here in Notepad++, just in case we need it. Next step is to start getting this into a program. So let's go ahead and create a new file. Let's do a save as, and this one we're going to call exercise 817 raw data. Sounds good to me. And the first thing that we're kind of tasked to do here is to read this stuff in and allow the user to query it. Now, this sounds pretty complicated, but step one is going to be, let's get that data read in. Now, because we're going to be dealing with a number of different types of data structures here, the first thing that I'm going to do is I'm going to set up a dictionary to work with. So let's set up incomes, and notice the use of curly brackets here to do that. Just empty right now, but it is telling us that it is a dictionary. Next thing that we're going to do is we're going to issue a command to open the file that we just created, and I called it raw data.txt. Oh, and that does have to be inside of double quotes here. Now, yes, I'm actually typing this in because I called it something different last time, apparently, because I'm looking at my cheat sheet. And we don't need to alter the data. We're just pulling information from it, so we're in read-only mode. So we're throwing the R switch in with the open command. All right, so here's where we have to do a little bit of work. So conceptually what's happening is we just set up an empty dictionary. We set up a read-in of a file, and it's stored into a variable. Now we're going to take the information in that variable, and now we need to break it down so that we can remove the stuff that we don't need. So if you look at the list the way it is, and let's see if we can get that on the screen here, there's a lot of stuff in here we kinda don't need. So first of all, don't really care about this number. I mean, it's equivalent to a line number. Our tools are doing that for us anyhow. That just shows the rank. Okay, so maybe that's pertinent, maybe not. The next piece of information is just the country name, and you know what? That seems to be okay. And I look at the money amounts here, and these are a little problematic. So this is an example of us actually cleaning our data here, because this data was formatted. So somebody took this from some other database, created this file for output. The problem is that the $sign and the comma really aren't relevant to anything mathematical. They're just formatting items. So one thing that we need to do is, I guess, look at this data, split things apart, and then we also need to go ahead and make sure that we clean out the $signs and the comma. So let's start by breaking the line apart. We're going to be processing data, so what you will discover very quickly is that a loop is really kind of a good thing for doing this. So let's start by just getting that loop going and then splitting the lines into pieces. Now the split command is going to take things and separate out the pieces into separate parts of the information. Okay. Now notice that I chose this variable named parts, that we will be able to take each line and split it into pieces. So instead of reading all of this in as one line, because if you see as I highlight a line, that's what we're reading in. And so we're just asking it to split this into pieces and then put stuff in there. All right, so it's breaking apart the line. Next thing that we're going to do is we're going to add a command here to remove the $sign and the comma from each of this. Now notice how it's like indicated, it says parts position 2. So parts really is a list, and we're looking at the second piece of information, which is really the third, right? So this would be 0. Right, the 3 would be 0, this would be 1, and then this would be 2. So that's why we're focusing that on 2. So in position 2, for any one of the lines we're splitting apart, we're removing the $sign, we're removing the comma, and replacing it with a blank. Next thing that we're going to do is we're going to issue a command to put the country into the dictionary. All right, so look at the syntax here. So we're taking first the float, So in other words, we're taking that number that we just cleaned up here, and we're now converting it to a number. And then we're going to place that into our dictionary. Now, you have to remember how dictionaries work. Dictionaries are different than lists, okay? And if you're making the comparison to other languages, the comparison is this. In Python, we call arrays lists, and then they have index numbers that indicate their positions within the structure. In other languages, we'll have what we call associative arrays, meaning that instead of an index number to access a value, we're using a name, a key name, to access the value associated with that key. So JSON does this very often. We have associative arrays in many languages, and you may have learned it first in maybe PHP class if you're a web student. All right, so what we're doing here is we're taking parts one, so what that means is whatever country name we found in the list, we're converting that to uppercase, and then we're taking the value that we're pulling here and storing it with that. So, in other words, we are setting up basically inside of incomes a dictionary where the country name becomes the key. So United States is the lookup to find the value. Okay, so that's kind of maybe fuzzy for you, but if you think about it in, maybe in JSON format, the key might be, I don't know, Italy, and then the value associated with that key would be whatever the number is, and those two things are going to be stored together as a key value pair inside the dictionary called income. And then to access the money amount, we type in the country name to find it. So see the strategy there. That might be a little fuzzy for you, but you know what? If you understand the concept of an associative array, or the dictionary structure inside of Python, where we use key value pairs to store information, that's what we're doing here. The next thing that we're going to do is we're going to allow the user, now that we've done all that mechanical work in the background, to type in a search. So we're going to allow them to type in a country name. And now you get the idea of why did we switch everything to upper? Now, in the dictionary, all the country names are uppercase, because that way when somebody enters a name of a country at the prompt, they can enter uppercase, lowercase, capitalized case, whatever. It will convert it to uppercase and then find it in the list and then display it. So let's understand that's what that's doing. Now, the next thing is we're going to set up a loop, and the loop is going to start like this, right? So we have a loop, and we have to search through our whole dictionary to find what we're looking for. All right, and notice we say enter a country name or type quit to quit. All right, notice how this is changed to uppercase because everything's being changed to uppercase. All right, next thing that we're going to do is we're just going to run a simple if statement to figure out where it is. So if the country that we've typed in is listed in the dictionary, we're just going to do the output. We're going to say the per capita income is the incomes relative to whatever country we're looking for. So it's going to find, so instead of looking up by index value, it's looking up by the country name, and then it's going to output the number that comes with it. It won't output the country name, it will output the number that's associated with it, which we stored right here. Otherwise, we'll just say, an error message of some sort, we can't find that, and then this is just simply to print the blank line, just to put a little space in between our stuff. And is this it? Yeah, this is it. There's nothing really complicated about this. So this really, once again, shows you some of the power of Python. A little bit of logic, a little bit of using some of these tools that are built in, quickly read in a large set of data, clean it up, store it in a way that we can search it, and then set up a quick little interface that allows our users to search the list and come back with a result. Let's save this. And let's go ahead and give it a run. All right. So it looks like I'm thinking I got an error message here, or is this from, yeah, it is giving me an error message. Let's see here. It says list index out of range. Line 18. Okay, and I think I know what the problem is here. So let me, okay, so this is, and my indicator says line 18, but it's trying to do this, and it can't do it. And the reason is, I think, because of this. So I think that maybe the original file that I used wasn't separated by spaces, it was separated by tabs. So here's how I'm going to find that out. I'm going to go back to my original file source here. Here's the beautiful thing, is this author does give us all these source code files, so they have that file available. So this is the file I used last time, and now that I'm looking at it, you guys can't see it, but here it is. If I go between, notice how these are all tab separated. Now this is spaces, whatever, but the columns are separated by tabs. So I'm actually going to, use, if I would have actually downloaded that file correctly, I would have that version of it. So what I'm going to do is I'm going to make a copy of this. I'm going to put it in my other folder for data analytics. Now, where do you get these files? So these come from the source code files of our Python book. Perhaps what I'll do is I'll attach this file to the assignment. I think that makes a lot of sense now that I'm thinking about it. All right, I'm going to delete my old file. Of course it's open. You know what? I don't have to delete it, right? I can just change what I have here. So I can just change the file name part of it. So I'm going to just right-click, rename, highlight it all, copy it, escape, come back here and just change the file name. Now I could have also, I think about this now, I could have also looked for the line split to be spaces, but okay, well, now I've done it, so never mind. You see like the wisdom in the aftermath. So now that we have the right file in there, I'm going to go ahead and hit play. So enter a country name. So let's put in Greece. I'm a little partial, right? Oh, we got a little bit of a problem here. What's our problem? I got an infinite loop going. All right. Did you guys know that you can hit the stop button here and make those stop? Yeah. So let's figure out how we got into an infinite loop. Real quick. Oh, duh, of course. All right. So we were in this loop. So we find it, but we just keep printing it out. I forgot to put in one more line here to end this loop at the bottom, and that's this. So we're kind of stopping it from running by putting in a prompt, which is the same prompt that we started with. And if you want to stop, you just type in quit. So let's save that. Let's run this again. And let's put in Italy. And then it just comes back one. So that time it worked. So now it's asking us to do another one. So let's do Ireland. All right. I don't know how to spell Liechtenstein, so let's do something I can spell. Germany. All right, so you kind of get the point here. And then if you want to quit, just type quit, and we're done. All right, so that's an example of that exercise. Now, since this video is getting a little bit long, I'm going to go ahead and stop this video. And I'm going to record a second video to complete the remainder of the exercise. So this covers, I think, the first 4 exercises in the assignment set. All right, and I will get this posted as soon as I can. This video is over.